Okay, let's take a look at deriving the cosine formula, or a squared equals b squared plus c squared minus 2bc cosine a. So what we're going to start here is we're going to consider a circle with a center 0, 0. So make sure to draw this when you're doing the explanation. And we're going to consider a triangle that is created off that circle. So I'm going to create this triangle out here like this. Let's put that there. I'll extend this little line here to here. And we're going to label each of the parts of it. So I'm going to say it makes this angle A, and this is side A. We're going to say this angle over here B, and this then is side B. This is angle C, and the side opposite is side C. So now with that would make this coordinate, and I'll write it here in black, C0. Whatever the length C is there on the x-axis, and 0. On the y-axis, or sorry, up here on this coordinate over here up the top. Now, just taking a moment, if we consider the triangle here, okay, I'll show you this, but you don't need to show this for the examiner, but it's just for your own understanding. If we take this to be a length B, and these two sides to be the x and y axes, if that's a length B, then what we can say is here that the angle that's being made with each of them is going to be made with this guy here. So if we take a positive sense of the axes, this guy here on this axis, I'll call him the adjacent, I'll call him the opposite. Then I can say cos A equals the adjacent over the hypotenuse, which means that cos A equals the adjacent, which is just the adjacent, over the hypotenuse, which is B. So the adjacent here is B cosine A. Okay, where that little a stands for adjacent. Similar idea, if I go for the other one, I'm going to say sine A equals opposite over hypotenuse, and repeating the idea, equals opposite over B. B sine A is equal to the opposite. Okay, so this coordinate then up here becomes B cos A, B sine A. Now you might be saying, Steve, I noticed that you used, like this was A, but you used a different A. It actually doesn't matter as long as it makes an angle A with the positive sense of the real axes. So I could have put it over here, for example, done the exact same diagram as here, and we would get to the same problem. So it actually doesn't matter playing around with that. So don't worry about that there. It'll always be B cos A, B sine A, as long as it's a positive angle here. Now, with that in mind, you don't need any of that stuff at the bottom. Like I said, you're just good to go once you've got a diagram drawn here with your different parts labeled. So now that we've got the different parts labeled, we're going to consider the distance formula. Your distance formula can be found in your formula booklet, and it's this guy here. And we're going to consider the distance from CO to this guy here that we just created. So with that in mind, let's label our 2 points. So we've got B cosine A, B sine A. I'm going to call this x1, y1, x2, y2. And now we're going to do our distance formula. Our distance is a length B. Our distance is the length A, because we're talking about the distance from there to there. So I'm going to say A equals big square root. Now I'm going to say x2, so C minus B cosine A to be squared, plus 0 minus B sine A to be squared. Square both sides, because we might as well start cleaning it up straight away. I'm going to get A squared equals C minus B cos A times C minus B cosine A, plus minus B sine A squared becomes B squared sine squared A. Next part is expanding some brackets. So take your time with the expansion. Okay, and now add things that look alike. So we've got these guys look alike. And in these ones here, you'll notice they share B squared. So I'm going to factorize out that B squared. Okay, now in our formula booklet, our rules on page 13 here, we'll see there's a rule here from our previous one that we also need to know of cosine squared A plus sine squared A equaling 1. So in that case, this bit in yellow here ends up equaling to 1. And we get a squared equals c squared minus 2bc cosine a plus b squared. And rearranging that, I get b squared plus c squared minus 2bc cosine a. Just remind yourself through, because it's always good to do a little walkthrough again. Your diagram is most important. You don't need to explain where you got all that. It's absolutely fine to just draw your diagram. Then we're going to say, okay, let's label our points as x1, y1 and use our distance formula here. Fill it in, and then remember to replace in from this rule here of cos squared a, sine squared a. And you get down to this derivation at the very end. Hope you found that useful. If you did, then like or subscribe, or check out the other social medias where I'll be adding extra resources. If you want something particular made, then just leave me a message on one of those platforms and I'll do my best to get around to it at some point. Best of luck in all your exams.